This is just a quick video for ionic and covalent bonding so that you can sort out how to give the proper formula if you're given the name, and the proper name if you're given the formula. So our first example we're going to look at is calcium and fluorine. You can see here I've included a periodic table, so we can take a look at that. And we've got calcium and fluorine. So first question you need to ask yourself is, what am I dealing with? What have I got here? Is this ionic or is this covalent? How do we decide that? Well, first we have to locate calcium and we have to locate fluorine on the periodic table. Calcium is over here. It's number 20. It's in the alkaline earth metals. So pretty good indication that it's going to be a metal. So we know that we've got a metal. Fluorine is over here in the top right with all the other non-metals. So we know that we have a non-metal there in fluorine. So a metal and a non-metal, this means that we have a ionic compound. So we do not need to use the prefixes with that because it's ionic. So therefore we can go right ahead and name it using their names without using any prefixes. So we would just keep the first one the same, so it's going to be calcium, and then we're going to keep the second item pretty much the same except change the ending to "ide," and we don't need to use any prefixes at all. So calcium fluoride. So not calcium difluoride, just calcium fluoride. The next example we're going to examine is H2O2. So hydrogen, again, we need to locate that on the periodic table, and there's hydrogen over there. Now, we have to remember that hydrogen is one of our special cases. It's over here on the left-hand side of the periodic table, but it is a non-metal. So we have one non-metal. Oxygen is over here on the periodic table with all the other non-metals, so it is also a non-metal. So we have two non-metals. Since we have two nonmetals, this is going to be a covalent or molecular compound. So in this instance, in order to use the proper name, we will have to use the prefixes. So there's the name there, dihydrogen dioxide. I have to use the prefixes because I've got two hydrogens and two oxygens. So that's why I need to use these two prefixes right here, dihydrogen dioxide. It's molecular, it's a covalent compound, and therefore we have to use the prefixes so that we know the recipe. Alright, two non-metals, that's how we were able to determine that. So, going from the formula to the name, you need to see if it's a metal and a non-metal. If it is, it's ionic. If it's two non-metals, then it's covalent. In our next example, we've been given the name of a compound, so now we need to know what the proper formula is. So there's a couple of things that you want to look for right away. First off, does our name include any prefixes? Carbon does not, but the second element here, tetra, is one of our prefixes. So right away that should try and indicate to us that it's probably going to be covalent or molecular, because only covalent and molecular for this year are going to use those prefixes. The other thing we want to look for is, just like when we were going from formula to name, is we want to see, do we have a metal and a non-metal, or do we have two non-metals? So carbon is over here on the periodic table with all the non-metals, so we have a non-metal there. And chloride is chlorine, and it is over here on the periodic table. So again, we have another non-metal. So pretty good guess here. I'm pretty confident that it's going to be a covalent compound, and sure enough, the formula is spelled out for us here because we have these prefixes. So carbon is just C. I know it's one carbon because there's no prefix and it's the first element, so that tells me that it's monocarbon, but because of lazy scientist rule, they dropped the mono. So I know I've got a capital C for carbon, and then tetrachloride, so chlorine, and I'm going to have tetra, which is 4. So carbon tetrachloride is CCl4. Our final example is lithium oxide. Now again, it's given us the name, so we want to know what the formula is. If I look at lithium oxide, I see that there are no prefixes in front. It's not monolithium, monooxide, or tetraoxide, or anything like that. So right away I'm kind of leaning towards it being ionic. If I go and look at the periodic table and find lithium, there's lithium right there, and I find oxygen, there's oxygen over there. So lithium is in the metals, it's in the alkali metals. Oxygen is over there in the nonmetals. So I'm pretty sure that this is going to be an ionic compound. I've got two clues that have helped me out. So with ionic compounds, when we want to know the formula, we have to use the old crisscross method. So the first step is to write the write the symbols. So Li and O. We then obtain their charges by looking at their groups. So lithium is here in group 1. So it's going to have one valence electron that it wants to get rid of. So when it does that, it's going to be +1. Oxygen is over here in group 16, 2 short of being full. These guys are 1 short of being full. These guys are full. So 2 short of being full means oxygen is going to go find 2 more negatives, 2 more electrons. So it's going to end up being -2. We then crisscross that and drop the charges. So that number goes there, that number goes there. We drop the charges, and we don't write the ones. Lazy scientist rule again. So this becomes Li2, there's that 2 there, and then O, and it would be O1, but we don't write the 1. So that is it. So hopefully that helps. If you have any other questions, please come and see me.